All right, fifth graders, we are going to do a presentation on ratio and continue our work through Learning Goal 3. Today what we're going to cover is just going to review quickly equivalent ratios, canceling ratios, and we're going to focus on writing our ratios in the form of 1 to n or n to 1. The rest of these we're not doing quite yet. Okay, so let's review the definition again. The definition is it is a method to compare the relative quantities of two or more items. For example, squash, and here squash is capitalized, which means it must be a drink or something, is made using the ratio 1 to 5. So when we have juice to water, it's 1 to 5. So for every 1 part of juice, we need 5 parts of water is how we would look at that ratio. We say juice to water in the ratio of 1 to 5 because we're saying juice first. So our 1 goes first, we're saying water second, so our 5 goes second. One thing to remember when talking about ratios is they have no units of measurement. So when we're talking, saying 1 to 5, we're not talking very specific 1. It could be any kind of 1, no specific unit of measurement. It could be 1 teaspoon of juice to 5 teaspoons of water. It could be 1 glass of juice to 5 glasses of water. It could be a jug of juice to 5 jugs of water. It can be any unit, but it must be the same for all. So if we're talking about jugs of water, we're talking about jugs of juice. So it's not unit specific, but we can apply a unit to it. When we look at equivalent ratios, so let's say we are making weed killer. It's a bad spring and the weeds have gone crazy. And we are going to use weed killing concentrate. And you look at the back of the bottle and it would say you need to mix the concentrate to a ratio of concentrate to water in 1 to 20. And so let's say it's 1 cup to 20 cups, but we know we need to make more than that. What if we knew that we wanted to use 5 cups of concentrate? We would then need to figure out how many measures of water do we need, and we use our ratios to determine what those measurements are. So if we look at, for every 1 unit of concentrate, we need 20 units of water. We're saying we need 5 units of concentrate. If we say we need 5 units of concentrate, we need to figure out how much water would we need to add. Too much water, and the killer wouldn't work because it would be too diluted. Not enough water, and the concentrate would be too strong, and we would kill anything and everything. So kind of like we do with fractions, we look to see what we did to convert one to the other. So in this case, to get the 1 unit to 5 units, we multiplied by 5. So we would do the exact same things to water. To get the 20 units, to find out how much we would need for this quantity, we multiply it by 5, and we would need 100. So we are saying that the ratio of 1 to 20 is equivalent to the ratio of 5 to 100. Another example, if the ratio of red beads to black beads on a bracelet is 3 to 5, which we're saying for every we have 3 red beads, 5 black beads. And then this is a part to part. 3 red beads, 5 black beads. How many black beads would be needed for 21 beads? Well, we're looking for equivalent ratios, and we set this up similarly to fractions. So we look at red to black. Our ratio is 3 to 5. And then we say, well, if we need 21 red, how many black do we need? We look for a common multiple to get from 3 to 21, and that would be 7. And so we would take our 5 and multiply it by 7. And we would have 35. So we could say the ratio of 3 to 5 is equivalent to the ratio 21 to 35. Another one, very common, mixing sand and cement. In order, you have to patch your driveway, you have to patch your sidewalk. You need to be able to make cement in the right way so that it does not fall apart. The ratio here is 1 to 3. Let's say we need 12 spades of cement. And here, when we talk about spades, we're talking about scoops of cement. That's the unit we've applied here. So first thing to recognize is we're doing mixing sand to cement to recognize that 1 represents the sand and 3 represents the cement because of the order. So once again, we write a ratio down, 1 to 3. And this time, we know how much cement we need. So we do the exact same thing, whether we know the first number or the second number. Here, to get from 3 to 12, we multiply by 4. So we know we need to do the other side. So we would need 4 spades of sand for every 12 spades of cement. Now we're going to talk a little bit about canceling ratios. And we cancel ratios. What it means is we're putting ratios in simplest form. Just like fractions, it's most easiest to read a ratio when it's in the simplest form. When you're given the quantity of each item, and you do this when you're given the quantity of each item and asked to convert it to a ratio. For example, with 4 red balls and 12 blue, what is the ratio of red to blue balls? Well, 4 to 12. When we divide, we find that least common multiple, and we can divide both sides by their greatest common factor. We can see they're both divisible by 4. When I divide both sides by 4, I get 1 to 3. So our ratio of red to blue balls would be 1 to 3. So let's look at this one. In a theater, there were 400 boys and 600 girls. What is the ratio of girls to boys? We look to make sure we're doing girls to boys. And in this one, we have to make sure that our girls go first. Even though in the statement it says there's 400 boys and 600 girls, you need to look at for what is the ratio they are asking for. And here they are asking girls to boys. 600 girls to 400 boys. First step would be to divide by 100 in order to make it easier. Then we'd have the ratio of 6 to 4. We would divide by 2 in order to reduce it to simpler form. And our ratio would be 3 to 2. And we can see that that would be in simplest form. All right, and now we're going to be talking about having a ratio in the form of 1 to n or n to 1. And as you can recognize, n there stands for a variable, so that number can vary. So what we want to do is we want to look at canceling a ratio until the item we are looking at is down to 1. So for example, we want the ratio of girls to boys in the form of n to 1. In ratios, when you're doing n to 1 ratios, they can include decimal numbers. So you don't have to worry about getting decimal numbers. When you're talking about 1 to n or n to 1 ratios, you can use decimal numbers. So let's look at our girl to boy ratio. We had a ratio of 600 to 400. And if we were going to take and we want to reduce this down so one of our ratios is to 1, it's easiest to take the ratio that has the smallest amount. So in this case, we're going to do 400. Well, to get 400 to 1, we would divide 400 by 400. And that is going to give us our 1. Now, when we're going for an n to 1 ratio, that's what we want. We want one of our quantities to be 1. To do that, we would have to divide the other side by the same number. When you divide 600 by 400, you get 1.5. So in this case, we have the ratio of for every 1.5 girls, there is 1 boy. All right, so let's take a look at this one. On a pool table, there are 6 red balls and 14 yellow balls. We want to give the ratio of red to yellow in the form 1 to n. Now, it's very important to look and see what ratio are we doing. We are doing red to yellow in the form 1 to n. Okay? So we have our red to yellow. We would write the original ratio. Because it says red, because it says red to yellow in the form of 1 to n, and we have red first and we have 1 first. This is the one we're reducing down to 1. So we're going to do 6 divided by 6 to give us 1. 14 divided by 6 gives us 2.3. So on a pool table, for every 1 red ball, there are 2.3 yellow. Now, that sounds a little odd because you're going, there can't be 2.3 yellow balls on the table. There either has to be 2 or there has to be 3. And that's where when you're talking about ratios in the form of 1 to n or n to 1, you can have the decimals. All right, that is it for now. So I hope you take your notes on the n to 1, 1 to n. We'll do a little activity on Monday. Have a great weekend.